ourselves. So I can start first. So why do I deserve to be interviewing in the first place? Well, as you may know, I got an internship at Square, so I'm kind of a big deal. So just kidding, just kidding. But I feel that this can be a learning opportunity for me as well to learn how to to learn how to interview. I think can be a valuable skill. And I think it can offer the opportunity for people that want to try out without risking to lose a job because they fail miserably, a chance to experiment. So that's why I wanted to do this. So we will be welcoming our guest. If you want to introduce yourself, tell us a bit about your background. What are your goals? What you're trying to achieve by practicing your interviews.
Okay, sure. I'm B. Wagerson. Some of the people here kind of see me message a lot. I frequent Larry's channel. Uh, just need practice. Hoping you got to just put yourself out there and practicing these things.
Yeah, for sure.
Hoping to interview at some larger tech company.
You want to get at Fang?
Yeah. Sometime in the future.
Oh, that's funny. I want to get in Fang too. Oh my god. Wait, I have to show everyone some video. I posted it earlier, but it's pretty dank, if I can say so myself. It was before contest, so it's been buried somewhere here. Golden boy, I love computers. So I don't know if this respects TOS, but I have to show it. And then we can start the interview.
Oh, I did see you posted that. Oh yeah.
So show me. Enough fooling around. Alright, so I decided to choose a hard problem for you today. And I think it's a pretty popular problem in interviews. I've seen it a few places around the web. And it's here on binary search under the name of Decode message. So here's what I'll do. I'll copy the problem statement here. And yeah, there's like all the companies listed here. So I think it's a good thing to study this question. So let's copy this here. And we'll be working in a REPL environment because when you're doing an interview, you can't use a judge to validate your solutions. So it's important to be able to prove that your solution is working yourself without relying on external help. So I think this should work. So yeah, the statement is pretty huge. So I'll read it for you and then I'll cede the wheel to you and then you will be in charge. So the question is called Decode message. So given the mapping a equals 1, b equals 2, ... z equals 26, and an encoded message encoded as a string, count the number of ways it can be decoded. For example, the message 111 should return 3, since it could be decoded as AAA, KA, or AK. So each one could be an A, or 11 could be a K, then 1A, or 1A and then 11 could be a K like this. So you can assume that the messages are decodable. For example, 001 is not a valid input because 0 is not in our table. So here's a few examples. If we input 111, the output will be 3 as described above. And then if the message is just 8, there's only one way to decode it as H. And 12, there's 2, it's AB or L. So good luck and have fun.
Okay. All right, let's see what I got.
So basically, try to explain to me what's your like instinct, what's your intuition behind this problem, and like we can do the time complexity and everything at the end, if that's okay. So do you have like a clue where to start when you hear this problem statement?
Yeah, let me, should I type, can type here, right?
Yeah.
Let me kind of about samples here. First example here, the number of ways. So if we were to just go through string and count the number of ways, we'd count a 1, then we'd get 11, or we could do we could do a 1, and a 1, or an 11 and a 1. Does it show my
Yeah, we can see it.
highlighting? Okay. So 1, 1, 1, 11 and 1, 1 and 11. If we were to modify this example and include a 2-digit string over 26. Reduce. We don't get this one anymore, right?
Yeah.
We get 2, 11 and 1, 7 and
Are you sure?
2, 7. Yeah, that should be. Am I mistaken?
Well, we can look at the problem statement again. So A is 1 and Z is 26. So if you were to match 27, what would that be?
Oh, yeah. 7 and we can't get any more characters out of those.
Mm-hmm. Yeah. Yeah. So I think.
Okay. So the thought process here is, so we're asked to count the number of ways to do something. Dynamic programming could be approach here.
Mm-hmm.
Because there's some, like, if we were to enumerate all the different ways, we could write up a cursive function to enumerate all the different ways of doing this encoding based on our rules. But we do have a bit of a pattern here. We can number of ways to encode a 2-digit string. if this, or a 3-digit string, there's a bit of a pattern that we're going to be able to do this 26. We're going to be able to do that twice, but if it was 27, we only get one.
Mm-hmm.
Let's see, I should go over the other what other cases too. What if we have a 0? Does 0 map to anything? 0 does.
I don't think you need to worry about that because you can assume that the messages are decodable. So there shouldn't be a 0. Because 0 isn't the character in any way that... Actually, I didn't say anything. Sorry. I may be mistaking you. My bad.
No worries, no worries. 0, 0, 1 will not be valid input. We can get 20, right?
Yeah, exactly. That's what I missed.
Okay. We can't do 0, so we can't decode individual. If we were to break it up into single digits for this one, we're going to get 20 and 1, but we can't do 20 and 0, 1, or 20 and 0 and 1. Okay. So I'm thinking dynamic programming. Because we have this relationship that we can leverage.
What relationship?
Say we have, if we know the number of ways to certain index, like this is going to give us up until the 0 index, we're going to have one way. Then we add a character. It's going to give us one way. This is going to give us had before plus 1. Okay, yeah, okay, let's see, let's find the this is just kind of pseudocode scratch that I'll be able to use.
Yeah, sure.
The number of ways to decode single digit. Just gonna be 1. Two, number of ways to decode things. So if this would be better to just start writing some. I guess so if we're gonna do dynamic programming, and I think the bottom up would be kind of intuitive for this. We would want states that we want to track are the indexes of the string. So the DP array would be length of string, I believe. I'd have to come back to that. And the number of ways to decode the first character is always just 1 because we can't have any leading zeros. Counting this is not okay. So if we know if it's not equal to 0, we're going to always add. We're always going to be able to add at least one more. Let's see, 90 equal. Yeah. There we'll get 2, and then we'll get a 6. There's 2, and then now all the cases of ching the 2 characters.
So right now, what are you trying to do?
If we're
Hello?
here, still here.
Okay. I don't know if the sound cut.
Thinking the current character is not non-zero. We'll always add the number of ways to decode the state before +1. Not at the 0 state. Oh.
So I'm curious what happens when you deal with the 2-digit case. And the code disappeared.
Yeah, I have a.
Okay, it's back. So before you code it, I'm curious how you're gonna handle the case where you have 2 digits, and if it's gonna work with multiple like 2-digit characters, I guess. Like let's say you would have something like 26, 26.
Yeah. So I'm thinking here, the only time we want to count another coding 2 digits is when we're greater, like 10 to 26. Can't count, we can't, if we look back 2 characters, the last 2 characters are not between 10 and 26. You can't add any more to make sense.
I'm not sure. Could you repeat that?
Like if we're here,
yeah,
and we look back 2 characters, so in this case we'll want to add one more decoding to our current state because 26 is a valid
okay, yeah, I get it.
code.
Yeah, that's good.
Opposed to well, so the 0, we could just imagine there's more characters before, but then looking back here and we're not, we don't want to count these 2. Or if we were at this state here, look back 2 characters and not want to count those 2.
All right.
Um,
Okay, looks good.
that should capture, right?
Yeah, I think it's good.
Right, so let me run through a few examples and make sure this. I feel that my let me run through the first state. We always have 1. One plus now look back. To
Just one little
Yeah.
thing. The audience is asking. Basically, when you're dealing with the 2-digit case, you're doing dp of x plus equal 1. Are you sure that's the right thing?
Oh no, I do. I definitely want to do.
Okay, just making sure. Yeah, I should point out like typos like that, I guess.
This is my algorithm here, roughly. I need to make sure that it runs correctly with some of these test cases. I don't get to just start hitting run test case like in a contest until until things work.
So yeah, I think it should be working.
So
Like, I don't see any big mistake. So I guess just proving that it works at this point, yeah.
of each state, every character in the array, and not in the array, in the string. Go through the string. If the current character is not equal to 0, we're always going to get not equal to 0. Always get one more of the previous state. And then to account for the 2-digit decodings, look back 2 characters. Let's see, no, we want to start from the first. Already did that one. Look back 2 characters, and if it's between 10 and 27,
So I
we
want
have 2 states.
to suggest another test case maybe. After you're done with this one, like just maybe like 4 nines like this. So without computing it, do you know how many ways to decode this message there should be?
Oh, just one.
Yep.
Yeah. So we don't want to add one there. Go back to characters we do add, because then we can that's when we make the choice. We can either do the 2-6 or the 2 and the 6.
But are you sure it would just add 1 to the current subproblem? Like if you had many ways to decode the part before the 26. How would that impact the current subproblem you're treating? Like if I can give you an example, like let's pretend there's like many subproblems here. Then you reach something like there's 6 ways here and 6 ways here. And at this point, you're at something, something, and 26. And your cursor is at the end of the 26.
So we would want to add the number of ways before. We had, let's say, k number of encodings in all previous steps, and then we can make the choice of choosing 26 or 2 and 6. So we would want, we have 2 new encodings. So we would want to do 2.
Are you sure?
I believe.
I think maybe like for a complete example, something like 26, 26, 26, it would be worth it to do it like quickly with the value of each subproblem. I think you can do it pretty fast.
Okay.
Because I'm not sure that's the actual recurrence relation. Just want to see if you see why.
First character, we get 1.
Yeah.
Character's not 0, so we.
So now we reach the part where you have both options. All right.
Okay. All right. No. We want to if we choose 26 as the way we're encoding, we add the number of ways to encode the last. So if we chose 26, we go back 2 states, and however many encodings there were for the state of x minus 2, we just add that to the number of ways at this state.
Easy
so you
clap.
want to do something.
Yeah, I think that's it.
Okay, let me just go through the example.
You won't hear that in an interview. Okay, I'm listening.
I'm happy with myself.
You should be.
Not looking too silly in front of stream here. Right, so we go back 2 states and add plus equals. All right, now we're here. Now the number of ways to encode that we encoded up to 26 was 2. So plus equals 2, right?
Yeah, so right now the subproblem is just 26, right? Or 26-2 rather.
Yeah.
So you can just enumerate it to see if it's correct.
Now we're at 6. We go back. But if we chose 26, we get all of those. Four ways up to 26, 26. Four ways up to 26, 26, 2. And then plus equals.
Yeah, sounds about good.
Okay, all right. I haven't been keeping track of the time of the clock here, but I feel
I think we're good. Like just writing some tests to see if it works, and like in like 15 minutes we can try to see if it works in on binary search. What do you think?
yeah, that sounds.
And last thing, after you're done with the test, we can talk about the time complexity and space.
Oh, okay, right.
We can talk about it after. Well, if you want to talk about it now, it's cool too.
I think I got, it's just big O space. It's just big O of n, where n is the size of the string of characters, and time is just big O of n as well. Because we just go through, there's no, we just have one for loop.
Mm-hmm. Okay.
Yeah.
It's that simple. So.
All right, so do I write, I test it in this window right here?
Yeah, we have to remove all the examples so we can actually run this code. So maybe like remove all the numbers up here, and you can write some assertions like assert solve of something equals something, and if there's an error it's gonna throw it, and you can put some message like this. You can do it like this and it should be good. Or you can just do some prints as well.
Okay. Yeah, let's. Users.
I can comment this. Yeah, okay. So.
Okay.
I think you commented. Yeah, okay. So, what do you think should be good sample test to see if it works?
This was, I think some of these are good. 26, 20. Should be, said that should be 8, right?
And it was with an extra 26.
With 28. Sure. The first one, right? 2, 6, 2. 6. And doing one more, we'll add, we have another choice. So, like, okay. We'll cover, yeah, and that 26, 26, 26 should be 8.
Mm-hmm.
What other ones? One. See. Add some of edge cases. That's going to give us it's 2, right?
If there's 2, can you enumerate them? Do you see a problem?
Oh yeah. Okay. Let's see, will that break, is my algorithm going to work on that one? It should just be 1.
Yeah, I think so.
Okay.
So I want to start with just these ones.
Yeah, this works. Or us, and if we solve it, so we passed. If not,
Looks good. I'm not sure you can iterate over the dictionary like that. Don't you have to put dot keys? I'm not sure right now.
I think should work, I believe.
Like this, yeah. Okay.
And then just click run, and
yeah, it should work. Except for the random numbers here, I'm just gonna comment them. There should be good now.
All right, moment of truth. Let's
all this moment, all this time. All right.
Odd literal for this time.
So let's say you're at position 1 right now. You would check between -1 and 1 excluded.
Yeah, I think I'm out of. That'll only give me a 1 digit.
Maybe printing what you're testing would help you visualize.
It should give me a 2 digit, correct?
Mm-hmm. Well, right now you're between -1 and, let's say you're at position 1. So if you're on the 6, do you want to include or exclude the 6? You want to include it, right?
Okay, right.
Yeah, I think that's it. So what's going on?
I solved
I'm just curious to see what's the actual answer returned by your function, because we can't see it right now. So 26 returns 2. So could we go through the first test that is not passing, the 26, and maybe look at the DP table? I think 4 is correct, so I'm just curious what your algorithm is returning.
saying 2, so this is one way, this is the second way, third way, fourth way, and I have 2, so going through x is greater than
What are you thinking about?
I think maybe my DP table needs. I think the index is here a little bit up. I'm at 6 here. I think I want to be looking back to the past previous to. Add up for the final answer. Because if I'm here, if x equals 1 and I'm at 6 here, I can't add up to dp of x minus 2. It just doesn't exist. So I think I want to have one extra element. Then go forward. One element greater than the size of the string. up like we can add up the previous. So here is when we're checking. I have here's where we're checking 2, and then here's where we're checking 6. So we can add up all the way back here.
No, I think that's good. So I think one thing that would be good is to basically we could bring out the DP table we had earlier, which is basically this, which with a bunch of 2s, right? And print the actual DP table that is computed by your algorithm. So basically we could compare the DP tables, because if there's a problem early in your computation, well, we could see it easily.
Okay.
Oh, I think I see it. Right now you're checking if x is greater than 0. Maybe it should be greater than 1, because you're doing 1 minus 2, which returns -1, so you're checking at the end of the DP table, which by coincidence is 0, so maybe it doesn't affect the computation, but maybe it does. Do you see the error?
Okay, if I'm pushing the DP table up 1 index, I have to push the string back 1 index.
Yeah, exactly. Past, 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 and past. All right.
Okay.
It's good. And I think it's about in the standard interview times. I'm not sure when we started, but my stream has been up for like 57 minutes. So like in a real interview we would like conclude here and maybe have like a little behavioral part where you ask me questions about the company. If you want to like practice that as well, for like why do you want to work at Google, and like do you have any questions for me even though I don't work there, you can do that. If since you didn't really prepare for that, like you don't have to, because it's kind of like putting you on the spot. And I'm curious to see if you put it in a binary search if it passes.
Yeah, let's. I mean, I don't have any. No, I
All right, no
what's
problem.
your favorite thing about running the stream?
I guess the interaction with the users. It helps me learn more about my craft, and I guess it's good because it makes you a little bit better at communicating. Like since I'm not like an English native, like I can struggle with that a bit. So I think like sometimes it's awkward talking to yourself in the mirror to practice interviews. So maybe streaming is a better way to do that. You know? All right.
Okay. Yeah, I feel you. Definitely coding in front of other people is a skill. Or coding in front of like whole stream
is another thing.
Another skill. Yeah.
So what do you think of the exercise? Do you think it helped you? Did you like it? Were you nervous at all?
It was fun. I liked it.
Yeah.
I think it's
Cool.
practice. Yes, nervous, definitely.
We have to be.
Definitely kudos to like Larry and Alex
Well, those
They're
guys are
coding
so
it.
good. It doesn't even count when you're that good. Like you're not stressed anymore, right, guys? Larry can confirm. I sent you the link to the problem and let me know if it passes. I'm curious. So like
Let's see.
other than that for feedback, I think like maybe try to like communicate what you're thinking more often because at some points like chat was like saying like I should like point out things to you and I wasn't sure if I should like give it to you or like let you figure it out, but like I never knew what you were thinking about. Well, I did, but at some times when you're trying to debug you were just typing things down and I wasn't really sure what you were trying to get at. And one other thing would be like try to visualize your problem more. Like I think like printing the problem out, I'm not sure if it helped you, but like it helps me have more context about what you're working on and like understanding things. And since you can see what the actual result of your algorithm is, like you can explain things better. So I think like visualizing and like never stop talking during an interview. Like the more you talk the better it is because you keep like the contact. Like to be honest, at some point, like if you don't talk to me for like a few minutes and I'm just looking at your code, I'm gonna zone out and like the odds of me like giving a good recommendation if I'm like zoning out because nothing's happening, you're just like typing, is like lower than if you're like continually keeping me engaged. So I think like never stop talking and try to visualize more. I think that would help you like come up with a solution faster. Like if you saw the DP table from the start, like maybe it would help you catch bugs earlier. I don't know if it's fair feedback because I know like I never did this before, so maybe I wasn't like that good of an interviewer. Like maybe I should have like probed you more, like some people mentioned in chat. Like other than that, I think like pretty solid. Like this question, I think is considered pretty hard, so I didn't go easy on you, like for sure. And you did manage, like I think will a little like help on my part, but you did manage to solve it. So I kudos to you for that, and kudos for your courage for sure. 5 to 8
What did
trust.
Larry say?
Yeah, Larry says that. I guess
Yeah, I
it,
definitely I feel you on continuing to like going because yeah, I haven't practiced this much. So you know how when you're like coding on your own, you start thinking, and you just kind of like zone into the problem.
mhm,
Like I think definitely like what you said, saying it out loud.
exactly. And like the interviewer is basically your friend, like he wants you to succeed. So if you say something that is like completely wrong, well, he has more odds of like correcting you like immediately that if you just think something but you don't say it, like can't really like correct you on the spot. But yeah, for sure it's a skill you have to
I'm
practice.
curious to see if I got this right.
Yeah, let me know. Yeah, interviews are more like about the social aspect at a certain point, like how well you can communicate your ideas.
Oh, all the indentation is messed up because
So yeah, I said at the start that I would ask the viewers if you would I hire you. What do you guys think? If you were a hiring manager at Fang, would you hire him? Mr. Broderick, software engineer at Google. What do you guys think?
all right, if you say no.
It's fine. It's fine. You're gonna get there.
I'm typing the problem in too. See if I.
Yeah, so what Larry says is pretty interesting. Like when you're doing an actual whiteboard interview, you're like forced to write the code down, so it becomes less about the code and more about like explaining the conceptual ideas, because you're not gonna compile the whiteboard, you're just gonna like draw the pseudocode at most. But it's how you communicate and understand the problem at a high level that is important. But I think you got to
accepted solution.
You got it?
Yeah.
Awesome, man. So yeah, that's pretty good. Yeah, because you jumped on like the dynamic programming idea pretty quick, so I guess that's already better than most candidates. If you like don't grind lead code, you maybe aren't so comfortable with dynamic programming. So I think that was good. I think especially for lower level, you should ask something easier and then have follow-ups. Okay, yeah. So I don't know about this question. Like here it says that it's like asked at a lot of companies. Maybe like at first, like I don't know what could be a simpler version of this. Like if you just ask like, oh, you can only have one digit. Well, there's only one way all the time. So maybe this question isn't really adapt to like follow-ups. But yeah, it's definitely a good point, Jonathan. Like at most interviews I've had, it's like at first they present like a simpler version of the problem, so you like gain the intuition naturally about it. One digit, two digit. Yeah, maybe. I mean, you could come to the conclusion that there's only always one way to decode it. It's like the problem. Maybe it would help you think. I don't know. I know one question I had in interview is the one you have to compute the volume of water stuck between like walls, and this one can be simplified to like what happens if like you only have two walls, and then you like take the min of both walls and compute like by the width, and maybe it can help you come up with the DP recurrence of like finding the minimum wall, well, the max wall to the right and max wall to the left, and taking the min of both. So yeah, but in the real world, I don't think you're always so lucky with questions. So I think it's a fair question. I'm starting to question myself, but
I was thinking it reminds me of your coin change problems or your
yeah,
it's or like your Fibonacci sequence.
Yeah, Fibonacci is perfect for like if you want to see like the basic level of dynamic programming, because I think you can figure it out without actually knowing what dynamic programming is, because it's like so natural. So that may be good. We can like go into the debate like how well suited are like algorithm interviews for like finding good candidates. Like should you be asking actual hard questions like this to find software engineers? That's another question. Like maybe just seeing if like somebody knows the basics should be good enough. But that's the reality we live in. We live in a society.
I don't know, I couldn't tell you.
Yeah, we don't get to choose anyway. If you want
problems
to get
are still fun. They're still fun to solve outside interviews too, so
oh yeah, well, for sure. Getting that lead code t-shirt, man, my biggest dream ever.
Reckless the on-site round. Didn't ask you now. Wow.
Yeah, some companies are like that. I think it's great. But it feels unfair to those who grinded lead code nonstop for like years. And then you get there and you have to build actual software, but you don't know where to start because you only know algos.
Yeah, it's tough.
Yeah, so maybe not for today, but if anyone else wants a mock interview, you can join my Discord, which I think I'll add to my Twitch links. So hopefully you can have as much fun as Broderick had today. And Broderick, thank you so much. You're like the first, so it's a big honor to host you, and I had fun as well. It's been something really
no
instructive
problem.
for me. So I'm just gonna add the link here.